Welcome to Lesson 10.5, Translations. Today we're going to talk about how to graph rules for translations and how to write rules for translations. First, we need to know what a translation is. So if you take a look at this witch riding on her broomstick, if she continues on the same path, she started here and now she is moving this direction. This is what we call a translation. More specifically, we have to talk about transformations. A transformation is a change in the position, shape, or size of a figure. So even if a figure starts as this tiny square and becomes a larger square, it's a transformation. If it starts in this corner and ends up in this corner but the same size, it is a transformation. If it changes from a square into a rectangle, it's a transformation. A translation is a transformation that moves each point of a figure the same distance and the same direction. Okay, so what this means is a transformation or a translation is a type of transformation, and it only moves the direction of the shape. It does not actually change the shape's size or the shape's shape. The image is the result of a transformation. So this is your after picture of your shape. So if this is your original shape, and you can use O for original or write original, whatever's going to help you remember, and then the shape moves this way, this shape is the image. It is the second shape. And then prime notation is the way to name an image point. Right? When we talk about prime notation, it'll usually have the point. So if the point is A and then a little 1 up top or a little apostrophe. This lets you know that this is not the original, but this is the second drawing, the image. All right, so what is happening in a translation? So if you look at these two rectangles and you take a look at where they start. So take a look at their vertices. If this is the pre-image or the original, then this shape down here is the image. And you have to match up the corners. So this corner down here is going to match up with this corner down here. So I'll make them both pink. And then this corner up here is going to match up with this corner here, here, and here, and then here and here. So what I can do is I can count and see how many places my vertice moved. So if I use the pink, I can start and I can look and see that first it moved to the left. 1, 2, 3, 4, 5, 6, 7, 8, 9. And then it moved down 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, so when I'm talking about this, I can say move left 9 and down 9. So then now all of these should follow that same rule. So for green to green, it should take me 9, 1, 2, 3, 4, 5, 6, 7, 8, 9, and then 9 down. 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, and you can check to see that all of these have moved 9 to the left and 9 down. The size of the shape didn't change, the shape itself didn't change, just its placement on the coordinate plane changed. Right, so if you look here, it asks what are the movements made by each point. So in this case, we've talked about this. You can look and see which vertices match up. And now here you can actually use your graph to count, or you can use your vertices to find the answer. So if I take these two vertices, it's kind of like when you were finding the slope, you have to take the change in x2 minus x1 and then y2 minus y1. So if you take the 2 and 3 and the -7, -5, and I take the -7 minus 2, that is going to give me a -9. So that tells me that this should move to the left 9. So 1, 2, 3, 4, 5, 6, 7, 8, 9. So that worked. And then my y, I would take the -5 minus 3, which is going to give me a -8. So it would move over 9, so left 9 because it's negative, and down 8 because it's -8. So I'm here, and I go 1, 2, 3, 4, 5, 6, 7, 8. So I know that the movement from each point, and I can check the math or I can count, is left 9, down 8. Now all the points always move the same distance. You don't just move this one up 8 and over 6, and then this one is up 7 and over 5. They're all the same. So in this case, it tells us to translate the figure by moving 8 to the right and 6 up. So I first take my first vertice, and I figure out where that first vertice is going to go. Now, I can either look at my coordinates and do the math, or I can just move it. In this case, when I'm trying to move the entire shape, it's easier to just find your points and plot them and then connect your dots. When you're trying to find the rule or what the movement was, it's easier to just do the math. All right, so we need to move to the right 8. So 1, 2, 3, 4, 5, 6, 7, 8. And then we need to move up 6. 1, 2, 3, 4, 5, 6. That's our first point. The next point, 1, 2, 3, 4, 5, 6, 7, 8. Up 6. 1, 2, 3, 4, 5, 6. Okay. 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6. Now this one's a little bit harder because you can't see the lines, so you kind of have to use the lines underneath. 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6. And the last one. 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6. Now if I connect all of my dots, I should have the same shape. It should be the same size. It's just moved from quadrant 3 to quadrant 1. Again, when you're drawing the shape and its movement, it's easier just to draw it and not do the math. And when you're trying to find what the movement was, it's easier to do the math. But everybody has their own preferences, so you can choose which one you like better and stick with that. Okay, so what I would like you to do here, I would like you to try to translate this shape. You're moving 4 to the left and up 3. When you come back, we'll check your answer. Okay, so now I'm going to speed this up a little bit, and I'm going to actually move the entire shape at once because I have the ability to do that. So I'm moving to the left 4, so 1, 2, 3, 4, and then up 3. 1, 2, 3. So this is where your shape should be. So now this top shape should be at negative 1, 2, 3, 4, 5, 6, 7, 8, positive 2. Alright, so now we're going to talk about what that prime notation would look like. So if this is the original, and this is the image, and we say that this is point A, B, C, and D, then this down here is still going to be A, but it's going to be A prime. And this is still going to be B, but now it's B prime. C prime, D prime. Now we know, without even having to have the words in here, which one is the original and which one is the image or the copy. Okay, so because there is no apostrophe here, that tells us that this is the copy and this is the original. Alright, so now we're going to talk about how to write the rule for translations. So this is where that change in x and change in y comes in handy. So if I take a look at my coordinates, and here's one vertice and here is its match. You have to make sure to find the match, because if you use this vertice and this vertice, it's not going to work out. So I can either count or do the math. In this case, I'm just going to count. I know I go up 1, 2, 3, 4, 5. So that tells me that my y is adding 5. Okay, so whatever my y is, I'm adding 5 to it to move it up. Okay, so we're at -1, and up here we're at +4, so that does work. And then I moved over 1, 2, 3, 4, 5. And since I moved to the right, that's still a positive, so that's still adding. So I'm doing the same thing to my x. I'm adding 5 to my x. So now if I wanted to know what my new coordinates would be, so if these coordinates are -4, -1, without having to do any counting or anything, I can plug these numbers into my rule and figure out what my new coordinates would be. So in this case, it would be -4 plus 5 and -1 plus 5. So my new x coordinate would be +1, and my new y coordinate would be +4. Let's take a look at that works. So here is its match up top. We move to the right 1 and up 4. Okay, so then what I want you to post on Edmodo is what this rule is in words. So what are you doing to the x and what are you doing to the y? Again, if you have any questions, please make sure to post them on Edmodo or write them down so we can go over them in class tomorrow.